Thank you. So my name is Carl Bergquist, and I work at Grafana Labs, and we're building open source monitoring tools. The most famous one is called Grafana, but we have others as well. And before that, I used to work for a fairly large auction site in a distributed system, and we had about 65 different deployable units at different scales and so on. And that's when I got really interested in monitoring to make sure that our system was running as we expected and making sure we were serving customers. So that's what I'm going to talk here about. And if we look at how monitoring used to work, it was basically you had a bunch of servers, and then you installed agents on these servers that were at a given interval was collecting metrics from the server, and then comparing these metrics like CPU, disk usage, I/O, and so on towards configured values. And if one of those values were violated, it would send a signal to the central monitoring server, OK, warning, or critical. The centralized monitoring servers was then responsible for making a decision, should I notify a human or not? And this has been kind of proven and works fine in a static environment. And also, the development process and deployment process looks something like this. You have two teams, the devs and the ops. And I'm not going to talk about DevOps. If you're curious about DevOps, please check Leonard's presentation from yesterday. But the ops team is really good at running stuff. And they're really good at running stuff when they have documentation, like Nginx, Apache, or something like that. They can parse documentation like no one. The developer team, they write code, and then they write documentation, right? You all write documentation before you ship your code to production. No. But anyway, so you ship your package or binary of some kind to operations, and then they are responsible for running your application without documentation. And this has been kind of OK, because we used to release like once a month or once a quarter or something. So the operation team was able to decide if this was a breaking change or they had degraded performance or something like that, by just comparing to how it used to work one day before or something like that. And if we start looking at the current tech landscape, we see a few big changes. Microservices, that's quite a big change. So going from a monolithic deployment, we now deploy maybe 100 services instead. And validating that the whole service system is working when you deploy one service is kind of tricky. Because even if the service you deploy is working, upstream or downstream system might not be working. And it might cause errors later, not at when you deploy it. And you deploy all these services independently. We also started using the cloud and containers and cloud native, which means that an application can start and stop like 3-4 times during an hour and move between machines, maybe due to deploy or failed start or something. So this is getting really tricky to follow whatever one application is doing, which you could do before. We also decided to start deploy a lot, like 10 times a day per service maybe. And then we also decided to enable feature flags. And let's say you have 10 feature flags per service. That means you have, and 100 services. That means you have, the system could be in 10,000 states per day or something like that. So we used to have a system where we change state once a month, and now we have 10,000 states a day. And then we ask someone else to make sure it's working. But how do we monitor that? How do we monitor an ever-changing system? Well, the first thing we need to do is to stop monitoring servers and start monitoring services. Rather than caring about high CPU, celebrate high CPU while the latency is low. It's kind of mental shift, but it's really working. And by starting to focus on symptoms rather than causes, we can make sure to find the problems, but not all the causes. So let's go back to the CPU and latency issue. If one server is having high CPU, but is still serving responses as according, it shouldn't be alerted or cause problems. Maybe the load balancer should not send traffic there, but it shouldn't notify a human. So those kind of problems will be caught if you monitor on symptoms. While if you keep monitoring causes, you cannot, it will be impossible to make sure you catch all the problems. And you need to start designing your system to expect failure. Because the monitoring system is not the end goal. It's just a tool you can use to increase system resilience. But you as a developer also need to start working on system resilience. So instead of sending database requests to a busy database server, make sure to have a fallback plan to dropping that request and maybe return an error to the user, or maybe return an alternative result. So an example would be if you have a product page in an e-commerce site or something, then you might want to show recommendation for that product. But instead of showing recommendation, you could fall back to showing top most sold items or something like that. And who can do this kind of work? Who can start building a more resilient system? Who can be responsible for that? I don't think that's up to the operations team. I think that's up to you, up to the developers in a company. And I think it's time for developers to grow up a bit and start acting as professional engineers. And if you cannot tell me how you know your system is running, then I don't think you're a professional software engineer. If you cannot tell me how many users are affected by errors, then I don't think you're a professional software engineer. If you cannot tell me the response time of your service, then I'm not a professional software engineer. If you make decisions based on hunches instead of data that you actually have available in your system, then I don't think you're a professional software engineer. If you care more about your unit tests and clean code rather than the stuff you put in production, then I don't think you're a professional software engineer. Don't get me wrong, I really love unit tests and I like clean code, but it's always secondary to whatever you put in production. That's the only thing that matters. Because remember, as an engineer, you're responsible for making trade-offs, and therefore also responsible for making sure they run as expected. You're never supposed to build the perfect system. You're always supposed to build a good enough system. And that's it for me. That's my short talk.